just great. No, I love it. My calculus question is all for me.
Okay, so this is just a hypothetical, but if me and Noah were to open up Spaghetti Store, would you go there over Spaghetti Shop?
I haven't been to Spaghetti Shop. So
Spaghetti.
but just for the name, Spaghetti Store. Sounds so much.
It sounds boring.
Boring, yeah.
Like your grandparents would shop. Spaghetti Store.
Alright, here's a better question.
Spaghetti.
No, it's,
You go to a Italy workshop.
Workshop.
Would you rather go to Italy or Italy?
I tell you because it sounds more professional. Right?
All right. Any problems on the IXLs? In other words, anything weird happening on any of the IXLs that you saw?
M10 or M12.
M12 and M10.
Those take forever.
Those take a while, yes, I agree. That's why I gave you extra time. But we can do it. Okay, now, so on these here, was it all sine and cosine? On all, we haven't got to all of them probably. I tend to remember now as I look at it. Well, here, hang on. So there's no way I'm still logged in this. Okay, let's just look here. So yeah, it's mostly it's really sine and cosine things, which is fine, and that's what our quiz is on tomorrow. Now we're going to go into tangent today, the graph and cotangent. Talk about those. It's very similar stuff as far as the graphs don't look similar, but as far as the stretching and the compression, and the shifting and all that stuff is very much the same. But the quiz tomorrow will be on the sine and cosine. So we'll kind of review that first here, and then we'll get into tangent, cotangent. I'll give you some assignment. The assignments can be on tangent and cotangent, but all of the stuff we've done here the last few days with sine, cosine is what's on the quiz. Okay, so it's basically draw a graph, give you an equation, draw a graph, give you a graph, you write the equation, give you an equation, and maybe you write down the amplitude, what the stretch is, or the period, what the vertical shift, what the phase shift is, you write that. Or like 80, 83, 85, I just describe to you the vertical shift, the transit, the different things, and then you write the equation. That's basically what it's going to be. So it's not going to be real long, and it's going to be those things right there. So you will have probably at least 3 where I'll just give you a blank XY axis and you have to graph them. So you have to do your marks, be careful with it, try to be really neat with the graphing of it. Okay, the rest of it will be where you're writing the equation or you're just describing what the different the period is. Okay, so that's the quiz. So let's just run through. So nothing on the IXLs. Let's go through 52, 58, 60, the 3 that you were supposed to graph, and then we can see if you have any other questions from those. Because the graphing part is the part that, well, we got to be more careful about, I guess. So on this one, so again, just to reiterate, amplitude and period, the non-rigid transformations, it's always best to do those first. That's the squeezing and the stretching and changing a period and all that stuff. So the amplitude and the period, that's the non-rigid transformation. Always best to look at those things first. So right away we see there's just a 1 in here, so we know our period's going to stay 2 pi. This thing's running out or something. And then the amplitude is 4. Okay, so we know right away, maybe that's going to be 4 right there, -4, whatever mark you want to be your 4, and it's still going to be 2 pi. So that allows you to put your marks on. We talk about the 4 marks, well, really 5 if you start there, and every trig graph has that, including tangent, cotangent, as we'll see today, kind of those 4 marks that represent the 4 quadrants. 5 marks if you include your starting point, but and so cosine. So I went ahead and did that here in the blue. The blue is stretched up to 4. So remember, cosine, of course, always starts up at its peak here. And then I got pi, halves, pi. But I separated it because, well, okay, back up here a minute. So now we can put in that cosine, but now we have a shift of pi 4. So probably, so we do amplitude period. So back up. So we do amplitude and period. We get our 4 marks. Normal period of 2 pi. It's going to be stretched up to 4. But then you say, okay, now I'm ready to go with the next part, which is the shift. And so when you see that you have a phase shift, which would be left of pi fourths, then all of a sudden you realize this mark's not going to work, right? Pi halves is not going to work. We'd rather have that be pi fourths, right? Which is halfway. Again, we could get common denominator. We talked about that between the period or what this mark is, what this mark is and this mark. So you got pi halves here, you got pi fourths. So you want to go pi fourths. Talking about common denominator. So that's a mark in between. Now, with my grid paper here, I could just make a mark in between. That'd be easy enough. Okay, I went ahead and stretched it out a little bit. So here's pi halves. Here's pi. I was talking to somebody yesterday when they came up on their graph, and what happened was that, Caleb, was that you had too many cycles, and so what he had done, was it this one?
I think it was a 58, but
it's the same idea.
Yeah.
So what happened was he had this, okay, and then he said, oh no, I need that to be pi fourths, so he put his marks in, but then what happened is instead of going down to that second mark, he went down to that mark, then there, and he ended up with 2 cycles instead of 1. So you got to remember, it's still a period of 2 pi. It's still a period of 2 pi, so we still want those 4 marks as our 4 important marks on our cosine. But we had to put in pi fourths because of the shift. So we needed half of pi halves, we needed pi fourths, so we needed more marks there to take care of that shift. Okay, so you just have to, so sometimes what I'll do on a case like that is if I change this to pi fourths, and so forth, then I'm just going to make those marks bigger. And just to remind myself, okay, those are my main marks for my graph. Okay, all right, anyway. Blue graph is the non-rigid transformation. That's just the stretch and the period change, which wasn't a period change. It's normal period. And then I said, okay, now I got to move over pi fourths. So 1 mark. So everything moved over. All the blue points moved left. 1 mark. Okay? And there's 2 full periods. And that's probably what I'll ask you to do on the quiz is 2 full periods. Okay? All right, here's 58. Yeah, I guess I did. So 58 is the same thing, but shifted up 4. Okay, same thing, shifted up 4. So, but this time what I did, again in the red, is I did the non-rigid transformation. So here's my marks. Here's my 4 important marks, for my graph there, and there. But I needed the pi fourths because of this shift here. And I'm going to shift up 4. So I went ahead and did the red graph, and I said, okay, now let's take every point. Let's go up 4. And left 1, or left 1 and up 4, whatever. So left 1, up 4. Right? Left 1, up 4. Left 1, up 4. So, okay? Here's the middle line. The amplitude of this is still 4 because it goes 4 up there, 4 up there. Remember, amplitude's always positive, so I ask you for an amplitude. If there was a negative in front of this, we would say 4 is the amplitude. Okay, negative is a reflection. All right, 60. So on 60, this was kind of a trickier one, but that's where we take out the 6. So if you take out the 6, that divides into pi 6 there. So our period, 2 pi divided by 6 is pi thirds. So that tells me I'm going to have these marks, which means this is going to be pi twelfths. 2 pi twelfths, this would be 3 pi twelfths, which would be pi fourths. Okay. I'm going to move pi 6 to the left. That's good. I got a pi 6 on here, so that's going to be good. Pi 6 is 2 marks. So this is going to go left 2 marks. Okay, so my markings are good. I don't have to mess with those. Don't have to worry about a common denominator or anything. Got an amplitude of 3, but it is going to be flipped. Okay, so the red graph is my non-rigid. That means I went ahead and flipped it down. So there's my negative down there for cosine. And then my period change, so I got my 4 marks in here, 1, 2, 3, 4, plus my starting point. There's my pi thirds period, right? So I've got so the red, there's 1 cycle, there's another. Okay, but then I want to shift it left pi 6. So that's, remember we said pi 6, that's 2 marks. So I'm going to go 2 marks left with every 2 marks left. Okay, there it is. So again, the points that I award for this, you're obviously going to be able to get some partial credit, if you got the amplitude right, you got the stretch right. you got some things, if your markings are bad or something, or maybe not as complete as I think they should be. I really have been, every time I've done one of these, I've been very, picky about that. I've labeled all those markings and everything, reduced them, I think is important. To get the full points on those graphs, I want them to be pretty nice. As I was walking around the other day looking at your graphs, some were better than others. Some of them were just pretty rough on your paper there. So try to be neat. Okay, try to be neat with it. All right. What's this one? I think that's one I was going to have. I wanted you to do right now. I can't even remember what on this. Was that a problem we had? No. Okay. So does anybody have another question that go away? I think it's out of the book. It's one I grabbed out of the book. I just want to have you do your time. Okay. So anyway, any other questions on 70? The ones in the 70s or the 80s?
You go through 70s. The three after that. One of them is
70. What were they?
76, 78.
Okay. So we had 76 and 78. Those are where you have the graph and write the equation. And then I'm not going to give you directions like they did with the ABC. Just write the equation. Okay. So yeah, let's go through one of those. So 76. Okay. So right away when you look at 76, how many periods did they show you on 76 then? How many periods are they showing you on 76? Anybody? I guess two. There's 2 periods, right? So that's the first thing to identify is find the starting point and then go until you get back to that point where it's repeating so you can identify. So they're showing you 2 periods. Okay, so what is the period then of that particular one? It looks like it's 2 pi, which is good. That's a normal period, so we don't have to make any adjustment there. So it's clearly been shifted down how far? 76. Looks like it's been shifted down 3. Now, what I might give you a problem like this is might just ask you, what's the period? Probably not on a graph, but period, I might just ask you to list. On the homework today, there's going to be a series of problems. Now, it's going to be equations, not graphs, where I'm just going to tell you to list the period, list the vertical shift, list those things. Okay, so the period's 2 pi. It looks like it's got a vertical shift of -3, is that right? Looks like it's down 3. What's the amplitude? Looks like the amplitude is 1, because from -3 it goes up 1 to -2 and down 1 to -4, and so that's the amplitude. Okay, and then it told us in the directions that it's cosine. Now we're going to talk about that. How there's more than one right answer. As a matter of fact, if you want to get really smart alecky about it, there's an infinite number of answers, right? For these graphs, because you can just remember how we talked, if you shift it over 2 pi, doesn't it land right on top of itself, and shift it over 2 pi again, and shift it over 2 pi again? And matter of fact, you can turn a sine into a cosine. We're going to do that here in just a few minutes. Okay, but they told you in the directions it was a cosine for 76. Okay, so what's wrong with this as far as being a normal cosine? It's flipped, right? It's flipped. So it's got to have a negative in front of it. So it's got a vertical flip. So we might just write that down, okay? And then otherwise that's it, right? There's no phase shift at all or anything. So what's that going to look like? That's going to look like y equals negative cosine. The amplitude is just 1, so there'd be a 1 in front of there. There's no phase shift. So the period is normal, it's 2 pi, so that's just going to be an x, and then a -3. So that's how you put those things. So you got to identify, right? Yeah.
So if you wanted to be careful, could you graph the original function and try to graph that based off that amount?
Off that picture?
So they have that picture, but you would graph the original cosine function and compare it.
Yeah. You mean as far as coming up with this answer?
Yeah.
Yeah, that could be a way to do it. Yeah, absolutely. You don't have to write these down necessarily. You can just sketch that. You say, okay, it's supposed to be a cosine, and sketch the original cosine, and let's compare it. Yeah, that's good, because visually you can see them. I think that's a good idea. Okay. 78, similar thing. 78 looks like a sine graph. It looks like the period is what? It looks like the period is 4 pi, isn't it? I mean, that picture goes from negative 2 pi to 2 pi almost, and that's one period. So it looks like the period is 4 pi, which means what are you going to have inside with the x? You're going to have a 1/2 in there, right? 2 pi divided by 4 pi. Just take the new period divided by the old period, or take 2 pi divided by the b. We're doing it backwards, so this would just be 1/2 is going to go in there. And otherwise, it doesn't look like there's a shift. It looks like there is a 2 in front. It looks like the amplitude is 2. So there we go, right? So that'd be 78. Okay, and then what other ones we have? 80. Oh, 80 was another graph. Okay, so 80 looks like it has an amplitude of 2. It looks like it's a cosine. But what does the period seem to be? Looks like the period is 4. It starts up high, goes down, comes back up high at 4. So that means 2 pi divided by something. 2 pi divided by something had to equal 4, or 2 pi divided by 4 equals what the b was, right? So what's that, pi over 2? So we're going to have a sine. We're going to have a pi over 2 x, right? Just 2 pi divided by the period should give you what goes in there. And then the amplitude again is 2. Oh, except it's not sine. My bad. Cosine, isn't it? Oh, yeah, okay, well, shoot. Okay, yeah, let's talk about that. Then this is what we're going to do later. They told you it's supposed to be sine, but is that wrong, what I just had? Is that wrong as far as what this graph would be? Right? Isn't this going to be a cosine graph? Amplitude of 2, it's going to have a period of 4, right? Because 2 pi divided by pi halves is going to be 4, right? And it's a cosine because it starts at pi. Now, let's bring in what the direction said. The direction said it's supposed to be a sine. Oh, well, how can that be if it starts up here? Shifted which way? Well, you can actually shift it either way, but which way does a sine usually start? It starts at the origin and goes up. So the simplest way would be if this point right here was shifted right to there. Wouldn't it be? If this point here was shifted right to there, then we would have a sine. Well, actually, we have to think of it backwards. If it was a sine, it should be here, but it's been shifted that way, right? So it's actually been shifted left. If this is going to be a sine, this has been shifted left, because this point right here where it's at the origin and starts going up, that point should be there if it's a sine. So this graph has been moved left. Well, how far is that? That's 1. If you look at where that point is on this graph, that point is at -1. So this has been shifted left 1. So what we do is we make this 2 sine. The pi halves would be outside the parentheses, and then this would be that right there. Now, I'm not going to tell you, at least that's not my plan, I'm not going to tell you have to make it a sine. If I tell you to write an equation for this graph, I will accept any equation that will make that graph be true. But it is a fact that any one of these graphs could always be written in terms of sines. If sine is our favorite trig function, then every time we see one of these waves, we can always write it as a sine. Always. Because sine and cosine are just shifts of it. Okay? Now, if we don't believe that, I hope we did that right. A little nervous about it. Okay, what did we say? What did we say there? We said y equals, it was negative? No. What did we just say? We said 2, well, let's do the cosine one first. Pi divided by 2, was it just that? What did it go from? Negative, let me see, let's go, the picture was negative, what's the x-axis in that picture on 80? negative 4 to 4. And the y, and it goes by ones. And the y goes from what? Negative 3 to 3. Something like that. Is that kind of what that looks like? Okay, so do we get it? All right, now what's the other one we said it was? Y equals 2 sine pi divided by 2 parentheses x plus 1. Right? There it is. They're the same. They're the same. Okay? It's just a shift. Because, I mean, think about it. I mean, if that's all we're doing is shifting, then a sine graph and a cosine graph, they all, think of the unit circle, they repeat the same values. 1/2 and square root of 3 over 2 and square root of 2 over 2, right? Sine and cosine have both of those values, so it makes sense that a sine graph and a cosine graph should share those values. And if you just shift them over, you get, you'll get that. All right, so let's go back here. All right, so that's pretty much that for the quiz. Okay, let's do a quick, on your paper, graph this one right here real quick. Well, not real quick, but let's graph that one. I'm going to put the answer on, so if you're finishing and don't want to see it yet, don't look. I mean, that would be about as involved in one as I would ask you to do in the quiz. The only thing that would get harder there is if you had to add in a different mark because of the shift, right? If you had to get a common denominators or change your marks to accommodate the shift. But this one turned out that the shift of 1 matched up with the marks you already had, right? Because you had a period of 4, so I'm guessing everybody got to that one, right? So you got a period of 4, so your 4 marks, the first mark will be 1, so that's good. So your marks are going by 1s, and you want to shift left of 1, so that'll work.
So what would that look like if we had to factor and shift? It'd just be not common.
Yeah, so in other words, what might have happened here is, let's say this ended up being, when you factored out a pi hat, you got x plus a half instead of 1. So now you need to shift left a half. Well, you look here, you don't have a mark that's a half. So what you can do is make each one of these a half, and then, you know, and then go from there, right? So that's when that happens. Yes. I just think so. Yeah. So so it's got a peak of 1, and it's got a low point of -5, right? So that's what I'll be looking for when I grade them. You got peak of 1, low point of -5. I just made these. I didn't label each of these, but yeah. And then, right. And it goes to 3, right? Your peak ends up at 3, right? Yeah. So that, and then just make another one.
And then your middle point's like -2. So
And the middle one in here is -2 right there. Yep. And that's at -2. Okay. Now you don't have to have that red one in there, right? I mean, the final one, if you want to sketch it and then erase it, whatever, but have it lightly. Just make it real clear to me. You know, make it very obvious what is your final graph. Okay. All right. Let's do this. I've got a graph up here. I'm going to have a graph up here, and I want you to write the equation. Okay, so there it is. All right, see if you can write the equation of that guy right there. Now, and see if so try it. Okay, that's the question. On the quiz, I will not determine that it has to be a sine or a cosine. I'm just saying write the equation that will give you that graph. So there are actually an infinite number of answers that would work, right? We just showed one where I wrote it 2 different ways and it worked, okay? Now, I think there's one that's the more obvious one that most of you would come up with, but you figured out, okay?
infinite number of answers.
Huh?
Can we put infinite number
No.
of answers?
You put one answer, and hopefully that one is one of the infinite number of answers. There's also an infinite number of wrong answers, right?
Yeah. But, so, I guess infinite answers. Can I get one of them right out of like 70? Do I get that answer right? Like, do I get full points?
Say that again.
Okay, so there's an infinite answer.
There's an infinite number of right answers.
Yes. So, let's say I put like 71 answers, and all of them are wrong, but except that one.
Okay, here's how I do that. If you're supposed to put one answer for a problem, and you put 2, right, then I average it. So so 1 was right, 1 was wrong, so you get half. And then minus half for not following directions, so you end up with 0.
So
If you put 70 answers and one's right, you get 1/70th minus however many points for not following directions, and now you're -7. So, does that answer your question? Does that answer your question?
So,
That's
that's 1.4%.
There you go.
I just said 1.4%.
Which, hey, that would raise your average. All right.
Let's see, minus 30%. 0 points. There's 0 points.
When you get done, you can get your Chromebook out, because we're going to do something on the Chromebooks next. So, and if you've got an answer, if you've got one of the infinite number of answers, try for a second one. Try for another one. Now, let me see a show of hands. How many people look at this and see a sine curve? Okay. Yeah, I would agree. Right? How many people got at least one answer they think is good? Okay, so a lot of you there. Okay, so why do we think it's a sine? Well, probably you look and you see it goes up to 3 down to -1. So it's obviously been shifted up, right? So it's been shifted up. It looks like 1, right? So the middle looks like it's right here. So right here, if this is our middle, right there, to me, that's our origin, isn't it? And so now it's looking like sine goes right like that. And, of course, everybody's here, so it doesn't matter probably in the video. But so it looks like my origin is here, and it's going up like a sine would do. And it's going around to here, which makes the period what? Pi half, right? So it looks like it's been shifted up. This looks like our origin. Here's a sine. There's one cycle of sine right to there. That looks like pi halves, which would tell me what? 2 pi divided by pi halves is 4. So it looks like I'm going to have a 4 inside of that sine graph. Hasn't been shifted anywhere because that's my origin, which is what I like, right? That's where a normal sine would be, so there's no shift, okay? But the amplitude is 2, and it's been shifted up 1. So when I was saying earlier that there's an infinite number of answers, but there's probably one that the vast majority of people would get, that to me is probably the one people would get right there. Okay, so now if I uncover this, okay, there it is. All right, now, let's find a cosine. Well, now, to find a bunch more sines that will be equal to that, then it's easy. Because to get this sine graph to shift and land on top of itself, how far do you have to shift it? How far do you have to shift a graph so that it lands on top of itself? 1 period, which in this graph is pi halves, right? So what we would have to do to get another graph that would be this one is either shift it left pi halves or right pi halves, or 2 pi halves, or 3 pi halves, or 4 pi halves, right? Just shift it over multiple periods, and it will continue to just land on top of itself. So if I show you one more here that I did, oh shoot, darn it. Never mind. Well, okay, I'll show you what I did. I was being fancy. But so anyway, you see what I mean? We can take this same one and we can shift it pi halves. Now what I did is I flipped it. Because another way to think of this is go over to this point right here. Okay? Go over to this point right here. And say that was your origin. Now where does that go? It starts going down. Well, what kind of graph starts going down like that? Sine if you've flipped it. So I said, well, maybe this is my starting point over here at pi fourths. So that means this graph the sine graph's been shifted left pi fourths. So I put it in as a left shift of half a period, but then flipped it. And that works too. You see what I mean? So you could just do this all day long and find the same graphs. Okay, so that's going to be one. Now, but let's pretend we wanted to make it a cosine. So what would we be looking for on this graph if we wanted to be a cosine? We'd be looking for the peak where it goes down. Maybe this one right here, right? So maybe it's a cosine that's supposed to be starting right here. Okay, well that means it's been shifted how far? Looks like it's been shifted pi eighths, right? So it looks like if I would shift that back pi eighths, or it's been shifted to the right pi eighths, that might have been a cosine graph. So if we look right here, I took that same thing with the 2 here. Okay, let me turn this one. Well, I was hiding that from you. So I can get this one easier. Okay. But if I turn this one on right here, lands right on top. It's just shifted to the right. Just a cosine that's been shifted to the right, pi 8. So I agree. I would have looked at this and saw a sine graph because of this right here. But a cosine would start here if you shift it to the right. So if you bring it back here, that'd be a cosine shifted to the right, pi 8. You get the same exact thing. Or shift it to the left, pi 8, and flip it. See this point down here? Okay, that would be a cosine that's been flipped, and it's over pi 8 to the left. So shift it left pi 8 and stick a negative on there, and you get it too. So, I mean, like I said, all day long, you can find different ones, okay, of these things. All right. But that's just an extra. You don't have to do it. I'm not going to ask you to find multiple answers for it. Just find one is going to be good enough. All right, what I want you to do is I created this, got kind of crazy this morning and thought I would try something here. And so I made this little thing here. We'll see how it works. So go here on your Chromebooks if you would, please.
Well, do it on my phone because I don't.
I think so. You can try it. I'm not sure how good it'll work. Go ahead and try it. Because your Chromebook is.
I didn't get the right charger from AJ, so yeah.
So it's his fault. Gotcha.
And mine because I want my.
What happened? Your old charger.
Well, the end that charges it kind of broke off inside. And, you know, I tried to put it back together and then it started sparking at me and I got scared.
Yeah,
So I kind of stopped that.
Probably not a lot of voltage in there, but maybe.
I just didn't want to die, so.
Yeah, well, that's probably smart. All right, so once you get in, you should be able to do the thing that is there, which is just to write the equation of that. And let's try not to get too fancy with it. Just stick with what would you think would be the most kind of common answer here. Because I don't want to take a whole bunch of time to go through all the different versions that it would be. Put a y equals in front of it too in your answer. Put a y equals in front, so that'll help me to.
Yeah, I gave you a warning that the screen's not big enough on my phone.
But it'll still let you do it.
Yeah.
Okay.
So this is just very difficult.
It's just not gonna. It's gonna be hard to see.
Okay.
Now I purposely didn't give a really nice markings on this one, so you're gonna have to kind of figure out. Now I'll be nicer to you on the quiz, but you're gonna have to figure out kind of the period. It's not gonna be. I don't think it's as obvious, is it? As some we've done. Because right now I have not seen the right answer yet.
Wait. I won't be typing the sign.
I haven't seen the right answer yet. And so what markings are you seeing on the x-axis? Pi halves and pi, right? What, I mean, now look at it though. I mean, look, ignore the pi halves. Well, I don't know that you need to ignore the pi halves actually, because doesn't it look like it hits a bottom there at pi halves? Right? So, what's the period? I don't think anybody's figured out what the period is here. If you've got a sine graph that goes to here, and the only value you know is that one, right? What do those other marks have to be? The only one you know is that bottom is pi halves. Huh? Don't each of those, I'm talking about the marks up, everybody look up here. Okay, now I'm starting to see the right answer. I see it from a few people here. But this is 1, 2, 3, 4. Remember how we count multiples of pi? So this has got to be 1 pi something, 2 pi something, 3 pi something, 4 pi something, doesn't it? So if this is 1 pi something, 2 pi something, 3 pi something, what's something? 3 pi what would make pi halves? 3 pi 6. Doesn't this have to be 3 pi 6? Which would make this 2 pi 6, which would make this 1 pi 6, and more importantly, make this what? 4 pi 6, which is 2 pi thirds, right? The period on this one has to be 2 pi thirds. Okay? Now, probably may not be that hard on you. If this was an honors class, I'd probably, oh, wait a minute. Wait a minute. It is an honors class. I should do that. I should do that. Right? So the period on this one has to be 2 pi thirds. And if you just look where that graph crossed the axis, it kind of looks like if you just took pi, 0 to pi, it kind of looked like that was divided into thirds, right? Pi third, where it crosses, if you look at those intercepts. So if it's 2 pi thirds, some of you are putting 2 pi thirds in your equation. That's not, you don't put 2 pi thirds in your equation, right? 2 pi thirds, the period is 2 pi thirds. So what's that mean? What do you got to do? 2 pi divided by 2 pi thirds. Once you figure out the period, then you do 2 pi divided by the period, gives you the number that goes inside. What's 2 pi divided by 2 pi thirds? Okay, put a y equals in front of your equation so they'll start showing up here. Okay, so now is it a sine or a cosine? Looks like a sine. Okay, it's got what in front of it? It's got a 4 in front of it. No shifts anywhere. And what'd you get for 2 pi divided by 2 pi thirds? Right? 2 pi divided by 2 pi thirds would be 2 pi times 3 over 2 pi. It's going to be 3. So it should be 4 sine 3x. Go to the next screen. 4 sine 3x. Okay, this one's marked a little nicer for you. Okay, is there a period change on this one? Looks like it's 2 pi period. Looks like a sine again would be the normal one, wouldn't it? But this one's been shifted up, what? Shifted up 1. Okay, but it looks like a sine. Now, it could be a cosine, but if it's a sine, it isn't shifted sideways at all. Okay. So 2 sine x plus 1. It's just got a 2 and then shift up 1. Okay, well, a couple more things to do when we get back. We'll just pick up right here. So you can just leave the Chromebooks. You might want to shut them if so they don't run out. I don't know if they'll run out of battery in a half hour, but.
I got you.
Yeah, I'm seeing some people with a 2 in front, right? I don't think there'd be a 2, right? Because it looks like it goes from 0 down to -2. So that would be an amplitude of 1. Remember, the distance between the high and the low is double the amplitude, right? Because amplitude goes from the middle up and the middle down. So if it's got a total distance of 2, the amplitude's just 1. Okay, it's got to be shifted. Which way is this one shifted? For sure. Not horizontal, I'm talking vertical. Isn't this shifted down? Got to be shifted down, right? Got to be shifted down. Okay, I'm going to go ahead and open up the next page. This is a card sort, so you can go to the next page if you think you got it, and then we'll check it here in a minute. Have you done one of these? Now, click on the graph. Yeah, click on the graph. It'll open up bigger so you can see it. Okay, so click on the graph so you can see it, kind of figure out. You might write it down on your paper and then see if you can find the equation that matches. Now, the hard part about matching is I might have written one of those kind of weird ones, right? You know, a shifted one where you might not think of it as a shifted one, which makes it a little harder to match. Of course, you can process of elimination figure that out a little bit too. Seth, you have one wrong pair. Luke, no, yeah, it doesn't tell you which one. Oh, you're trying to do it on you're doing your phone. You got one right pair though now. So that was right. Lucas, you got one wrong pair. Corbin, one wrong pair. Addie, one wrong pair. Chloe, one wrong pair. No, now you took it off.
What I did. There we go.
Taylor, one wrong pair. By the way, the one on the page before was what? Cosine 2x minus 1. Cosine 2x minus 1. Again, some of you had a 2 on the outside. There wouldn't be a 2 on the outside, I don't think. Now, there could have been a shift also. You could have done one with a shift or something. But Jack got one bad pair. So if I haven't called you out, no, you got one right, one wrong. Nick, one bad pair. Now you're good. Jeremiah, yours is good. Chloe, yours is good. McKenna, one bad pair. Taylor, one bad pair. Charlie, one bad pair. Noah, one bad pair. Lindsay, one. Now, Lindsay, you have two. Noah, you have two bad pair. McKenna, one. Charlie, still one. Oh, no, Charlie's went away. Addie, one bad pair. Two are good, one's one bad. Lindsay, now just one. McKenna, just one. Noah, two still. Oh, click on the graph. Click on the graph and it gets bigger.
That makes it so much.
Gee, I should have said that earlier. Oh, wait. McKenna, two bad ones. Noah, two. Lindsay, one. Allie, one. Jacob's good. Claire's good. Charlie's good. Chloe's good. Cade's good. Kale, are you on this thing with us? Huh? That's a good way to not get any wrong. Don't answer. Noah, you're good. Nick's good. Noah's good. Seth's good. Lindsay's good. Claire, Jacob, Jeremiah, Chloe, Charlie, Kate are all good. Addie, one bad pair. Taylor, one bad one. McKenna, two bad ones. Addie, two. Allie, yours are all good right now, I think. Kale, you got one right. You got a good one, attaboy. Caleb, yours are good so far, I think. Jack, yours are good so far.
You done?
Yep, you're good. Corbin, yours are good so far. All right, I'm going to pause you right there. Oh, you're just about to have it? All right. Set those aside. Go back to your notes here. And so that's what I'm looking at, right? So, all right. All right, if you've got, you don't have, I mean, if you've got it, would be good. The tangent, remember that we did the tables that day with sine and cosine? Did we even fill in tangent? Yeah, I had you fill in tangent, right? So if you've got that, you might try to find that and pull that out. And so what we're going to do here is do a quick plotting of the tangent graph. And then, so that will give us, so while you're looking for that, that will give us our sine, cosine, and then tangent graphs. And then we'll begin to get the other three, the reciprocal ones. So we'll talk a little bit about reciprocal today, and we'll apply that to the cotangent graph, and look at that. Then you'll have a few homework questions on tangent and cotangent, a little bit of graphing. But again, you'll want to be reviewing and refreshing sine, cosine for the quiz tomorrow. But we've been doing it for multiple days. I think we're probably about it. You can practice that. You can go on Desmo, so you can still get on this. Hopefully, if we have a little bit of time left, maybe you can finish up your matching. But I'll just leave it up, so you should be able to get into it and continue doing it at home or whatever. Okay, so here were some of these tangent values that we were getting. Okay, so we start at 0 and pi 6 and pi 4 and go. So the tangent was 0, 0.58, 1, 1.73, and then undefined because you're dividing by 0. Pi halves, you're doing y divided by x. You're doing 1 divided by 0, and that's undefined. Well, what's a graph look like if it's undefined? There's no point there, right? Now, I know in Algebra 2 you talked about asymptotes, right? You get into asymptotes? Vertical asymptotes on graphs? You ever heard that word? Yeah. Oh, you have. Okay. Well, anyway, that's fine. We're going to learn about it right now, if you don't remember. Okay? And then those values kind of repeat going backwards, but negative, and then they repeat again, just like it kind of did with sine and cosine. We start seeing those same values. Okay, so what's going on? Well, if we plot those, if we would go into here and we would start plotting these values, what we would notice is they repeat every pi units. Matter of fact, a good place to start is right here at pi halves. And, excuse me, if we start right here at pi halves, we see negative 1.73, negative 1, 0.58, negative 0, 0.58 positive, 1, 1.73, back to undefined. So from pi halves to 3 pi halves, we see this set of values, and then they all start to repeat again. And that's a distance of pi units, negative pi, or pi halves to 3 pi halves. So tangent does have a period of pi. So I went ahead and you don't need to necessarily plot this with me right now, or you can do a rough sketch, but I don't care about that until we understand. We did it with sine and cosine, but we understand now that there's going to be some important marks, some important points. Once we get those in, we can just fill in our curve. Okay, so we'll just go ahead and do that. There's no need to plot them all right now. But if I did go through there and started plotting these, okay, like pi 6 and these points and so forth, it would look something like this. Pi 6 was about here. It was 0.5, so right here about 0.5. We get this point, and then we had 1, and then we had 1.73 if you go back to these points, okay, so 0, 0.58, 1, 1.73. So we were here, and then here, 0.58, and then 1, and then 1.73, and then undefined. This is called a vertical asymptote. It's pronounced, or it's spelled like that, asymptote, and it is a place on the graph where it's undefined. Okay? Now, if we look, when we go past where it was undefined here, then we're back down at negative 1.73. So that's this point. So right past here, negative 1.73, negative 1, negative 0.58, 0, 0.58, 1, 1.73, undefined. Well, what's happening is if we connect these, is it's coming in like this, kind of curving a little bit, and then coming up, and it's just going to run right alongside this asymptote. If we would get closer and closer to 3 pi halves, we would be getting bigger and bigger numbers. So unlike sine and cosine, which are topped off at 1 and negative 1, the range for tangent goes from negative infinity to infinity. They have arrows on the ends going both directions, and it's like it's trapped in between these vertical lines, these vertical asymptotes. Okay, so pi halves, it's undefined because you're doing 1 divided by 0. 3 pi halves, you're doing negative 1 divided by 0. Tangent is undefined. at those places, but it's getting steeper and steeper and getting closer and closer. And then what you notice is it just repeats. So this is coming along here, and if we were going to do the rest of it, it would do that as well. And here we see this part of the branch, and if we repeat it, it would come over here, and you just have a series of these repeating branches, like so, okay? If we look at it here, if we remember when we did sine, remember on the unit circle, sine is the y, okay? Let me hide that. Sine is the y, so we were graphing the y coordinate in the unit circle, okay? And then cosine is the x coordinate of the unit circle. So that makes sense. The x coordinate's getting smaller and smaller. Now it goes negative. That gave us a cosine graph. But what's tangent? That's a weird one. We never really talked about what tangent is in the unit circle. Well, we did. It's opposite over adjacent. It's the y divided by the x, right? Tangent is the y divided by the x. So when I start this, they draw this thing here. So what is that? Well, that's the y divided by the x. Now, if we think about it, let's think about why that line there would be the y divided by the x. Because if I take this as my y, divided by my x right here, okay? Do you notice this creates two triangles right here? See this triangle and see this triangle? What would those triangles be called? Similar triangles, right? So, isn't it true that this over this should be equal to this over this? Wouldn't those be corresponding sides? Wouldn't they be in a ratio like similar triangles do? So y over x should be equal to this length over this length, right? Well, what is this length? 1. So y over x should be equal to this length over 1, or just this length. So does it make sense then that this length right here is the tangent? Right? That length right here is the y over x. So what happens then as this point, so it clearly starts out at 0, and as this goes up, that length gets bigger and bigger and bigger and bigger until what happens right here? No triangle anymore. And it's infinite. It's undefined. And to be honest, I always tell my Algebra 1B when I teach Algebra 1B, which is always a lot of fun. When I teach that class, we always talk about why is 1 divided by 0 undefined? Why can't you divide by 0? You guys know? Algebra 1B kids are smarter than you.
Yeah, it's Siri. She just gets mad at you.
Well, that is fun. Yeah, Siri, right? The 0 divided by 0. Have you heard that one? Well, we don't have time right now.
My friend told me this.
The Cookie Monster, the one with Cookie Monster.
There are 0 cookies and you have 0 friends. That's what she says.
Cookie Monster stacked with your
Yeah.
stacked with your friends.
If you do 6 divided by 0, it says something about if you had 6 things, it's trying to divide it into 0 groups, so that doesn't make any sense. But if you do 0 divided by 0, yeah. You have 0 cookies divided by 0 friends, and Cookie Monster said because you have no cookies, and you have no friends. What?
But it's okay.
It's kind of
Trying to explain it, isn't it? Because 0 is basically the same thing as infinity.
Well, no, 0 is the same. 1 divided by 0 is basically the same thing as infinity. But here's why. Because when you do 1 divided by 0.1, what's that? Quick. 10. What's 1 divided by 0.01? 100. 1 divided by 0.001? 1,000. So as you get smaller and smaller numbers on the bottom, when you divide, you get a bigger and bigger number, right? So what happens when you put a 0 on the bottom is you're trying to divide by the smallest number. And so if you divide by the smallest number, the answer should be the biggest number. And there is no biggest number. So that's why dividing by, oh, look at that, all these years. Right? There is no biggest number, so therefore, it's got to be undefined. It cannot have a value. Okay? So 1 divided by 0 is technically, it is like infinity. Now, infinity is not a number, so we can't, it's an idea, it's a concept, it's not a number, okay? So infinity is not a number. There are different sizes of infinity. Okay, you can stop there. You know, I normally wouldn't tell you this story, but I'm not going to be teaching you calculus, so it doesn't matter. But remind me tomorrow, and I'll tell you about the Infinity Hotel. But don't ask the calc students about what they think.
All right.
But, okay, listen. If we get time at the end, I'll tell you. All right, now, so this line's a tangent. So it's clearly getting bigger and bigger and bigger until we get up here, then it doesn't exist anymore. Now, when we flip it over into this quadrant, now all of a sudden it's negative because now your y divided by your x, positive divided by negative is going to be negative. So this line's negative. So that's why it's way down here. And here it comes. Here it comes right here at 0. Now it's going up again. Now it's positive because your y and x are both negative now. So when you divide them, you get a positive. So there it is. Okay, so that's why the tangent graph looks like it does. Okay, you get those bigger and bigger values. All right, so let's take a look at our tangent graph right here. And so, I mean, if you just want in your notes to make just a quick little sketch of this kind of thing, you certainly can do that. Let me change the color on this. Oops. Come on. There we go. So it matches. All right, so our y-axis is right here. So we have asymptotes at pi halves and negative pi halves. Okay, we've got these points going here like so. Now, one of the things we did with sine and cosine is we marked our important points, right? Now, we talked about the period. Well, this time the period is pi. Okay, the period is pi. Now, we could come over here and mark at pi if we want, but that kind of, if we go 0 to pi, notice we have like half a branch here and half a branch here. I'd rather look at this, when I look at the tangent curve, I'd rather go from here to here and look at one branch of it. So it's negative pi halves to pi halves would be our pi distance we're going to look at. Now, there are, again, 4 important marks with the tangent graph. Okay? If we go one period, it would be these marks right here. Well, it's really 5 marks. We've talked about that, 5 marks if you count the beginning and the end. But it divides it up into 4 special segments. Now, what are the special segments of that? Well, on the left edge is your asymptote, right? You have your asymptote over here, okay? Then at the next one, you have this value right here. Notice how that's at -1? Now, that's a little bit like sine and cosine. Have their peaks at 1 and -1. Now, in sine and cosine, we call that the amplitude. We don't call that amplitude with tangent. Remember, amplitude is just saying how far above and below your middle are your high and low points. There are no high and low points for tangent. So amplitude doesn't make any sense when you're talking about tangent, okay? Only for sine and cosine. So we'll just call that our vertical stretch. No, okay? Our vertical stretch factor, all right? Because that's what amplitude is too. If you have a 2 on the outside, that's your vertical stretch of 2. It makes it go up 2 and down 2. So it's still the same thing. It just doesn't, it's not right to call it amplitude, okay? So that's 1, and then this is right back at 0, and then here it's back to 1 there, and then here again we have our asymptote. So if we do a vertical stretch, imagine taking this little S-shaped thing and stretching it, it's just going to look pretty much the same. It's just going to be a little straighter. It's not going to curve quite as much right through here. It'll just straighten it out more, okay? Because what will happen, if you put a 2 in front of tangent, well, guess what? This point right here is going to be where? Right up there. And this point here is going to be down here. And so it's just going to be a little straighter as it goes through. But that's an important point I'm going to want you to plot. Now think about it. What's happening at pi fourths? What's tangent of pi fourths? Think of the unit circle. That's 45 degrees. What's happening there? The x and the y are the same. Root 2 over 2 and root 2 over 2. So when you divide y divided by x, you get 1. The tangent is 1. So at that point, halfway in between, that's your 45 degrees, and that's where you get your 1 and -1. Okay, so it makes it consistent with our sine and cosine that we have those 4 marks. Okay, the outside marks are going to be where the asymptote is. The middle mark in there is where it's going to cross the axis, and then the 2 marks in between there are where it's at 1 and -1. Okay, so if we stretch it, those would change. Those would be like our amplitude numbers. That's what would change, but it would still have that same basic thing. Now we can change the period, right? If we shrink in the periods, we'll still have those 5 important marks. We'll have the 2 asymptotes on the outside, okay, and so forth. But remember, the tangent does start there. All right, the cotangent graph, okay? Now, I've got to do this just quickly. Don't worry if it's right now in the quiz tomorrow. We'll talk more about it later on. But cotangent's a reciprocal. So if we took all of these values and did the reciprocal, we would have cotangent, the y values. Now what happens right here when you take 0 and do the reciprocal? Oh gee, we just talked about it. What's the reciprocal of 0? 1 divided by 0 is what? Undefined. So guess what? Cotangent's going to have its asymptote right here. Right here at pi, where it's 0, cotangent's going to have its asymptote. Where these asymptotes are, what's cotangent going to have? The other way around. That's where their infinity, the reciprocal of that, essentially, is 0. So where these asymptotes are is where cotangent is going to have its zeros. Okay, so the zeros or the intercepts and the asymptotes are just going to switch when we get cotangent. So we put cotangent on here. Oh, oops, by the way, I wanted to put 2 tangent on there. So see, you can see what I was talking about. So at pi fourths, we got 1, but if you put a 2 in front, stretches it up to 2 and down to -2. So the blue graph is what it looks like when you just stretch it there. Okay, all right. And so cotangent. Okay, so there's cotangent. Now what else do you notice about cotangent? The asymptotes we said are opposite. Instead of pi halves, negative pi halves are 0 and pi, so forth. Still a period of pi. Crosses there in the middle. Right here you got 1. Right over here you got -1, right? But what else do you notice different? It goes the other way. Remember, tangent goes up this way. Cotangent goes down this way. Almost like it was flipped vertically. Okay, kind of a thing. All right. So, could you get tangent, turn it into cotangent by flipping it and shifting it? Sure. Right? If you flip tangent and then shift it, you get cotangent. That's true. Just like sine and cosine, you can move them and turn one into the other one. Right? Okay. Anyway, that's just a quick look at what the basic tangent graph is. Remember the difference. Pi, period is pi this time. So when we put a number on the inside, we're going to do pi divided by that. Right? With sine and cosine, we did 2 pi divided by that number. It's whatever the normal period is divided. Okay, so with tangent, our period is pi. Period is pi. Okay, so that's basically it for tangent and cotangent. So there's a few questions, not a lot. You're going to try to plot a few, points. There's a few of those to graph. Now on these, these are all on the same page, but these 4 right here, it says to use your graphing calculator or Desmos or something to plot them. I don't care about that. All I want you to do is just list the shrink stretch, the period, the phase shift, the vertical shift. Now by shrink stretch, I mean that number on the outside, the vertical. Because remember, amplitude's not a factor here. We don't call it amplitude. So if there's a 2 on the outside, say, hey, it's a vertical stretch of 2. Okay? If there's 1/2 on the outside, that'd be a shrink by a factor of 2, basically. Or you could say it's a stretch of 1/2, I guess, which is a stretch of 1/2 is really a shrink. But, okay, we'll talk more about that later. But that's all I want you to do on those last 4 is just write that down. So that didn't take very long. I think 15 through 18, you try to draw some graphs. 27, 28, 38, I think they have you write an equation based on the information they give you. Very much like we're doing with sine and cosine. Okay? So, the Infinity Hotel. There's this hotel that has an infinite number of rooms. And it's full. Every room has somebody in it. And somebody comes and wants a room. And the manager says, well, we're full, but you know what? We can fit you in. So how do they do it? How do they fit them in?
They subtract 1 person.
You cannot subtract 1 person.
Dang it.
No, they're not going to add any rooms. They can fit them in. They can fit this person into an empty room.
He's already there.
No, there are no empty rooms. The hotel is full. Somebody in every room. Somebody needs a room. He says, you know what, we can do it. How's he doing? Okay, you figure it out and tell me tomorrow.
Wait, can I say how the infinity thing ruined my childhood right there? So,
Infinite number of rooms.
one divided by 0.
All full.
Right?
How does he get?
It could be an infinity. That's fine. Buzz Lightyear goes to infinity and beyond. That means Buzz Lightyear is going to that undefined place. He doesn't know where he belongs. Good one, Jack. I like that. Buzz. Stop.
Oh my goodness.
Oh, by the way, I unpaused. I'll unpause this.
I'm shedding tears.
I paused that. You have to go back in and try to finish it. Oh, yeah. Didn't we do registration last week?
Yeah, we got it.
Chicken.
Well, you're not gonna be teaching it, so I'm
You-
afraid.
Oh, God.
Would you shift everyone up a little to make room for that?
Yeah, now there's more to the story, but right, tell everybody to go to one room that's one room. Right, yeah, yeah. Now, there's gonna be more to the story, so we'll talk about that tomorrow. So if I was gonna be here, that's what McFadden was trying to.
Even if you were here,
McFadden's trying to tell me that if I was gonna be here, he would do it. He would do it.
I take it
I don't
into
know that-
consideration and.
You might think, see, that's probably why I retired, because I like you guys too much, and it's kind of like my daughter taking calculus. She didn't, and it's probably good, because
She
we
did?
would have, she didn't take it.
Oh.
And it's a good thing, because we would have killed each other. And we literally would have killed each other. Because, oh, God, Kelsey, well, you gotta know Kelsey, right? I mean, she's, I don't get it. You gotta explain it right. That's stupid. Oh, I would have killed her. There's no way I could have made it with her. There's no way.
I did that once.